off lesson 7.2. Again, we have a real life problem. We're going to still we're trying to figure out linear systems with real life problems. This time it's a museum admission. In one day, the National Civil Rights Museum in Memphis, Tennessee collected $1,590 from 321 people admitted to the museum. The price of each adult admission is $6, and people with ages of 4 to 17 pay the child's admission, that's nice, of only $4. Estimate how many adults and how many children were admitted that day. Okay, we have that we raised $1,590. So we have, and then we know also that there was 321 people. We do not know how many of those people were each of those categories. So setting up our verbal models, one equation would be that we know that the number of adults plus the number of children is going to equal the total number of people admitted. Okay? We do not know the number of adults. We do not know the number of children, but they're different. But we do know that the two of those combined are going to equal 321 people. So you can see we're starting to work on two variables in an equation. As we look at the next one, we're going to say, again, we do not know our number of adults, but we do know the price of admission. Price of admission for adults were $6. Even though this is written this way, I'm going to go ahead and write my coefficient first, and we still do not know this one, so this one would be 6x. We're going to add that same kind of price of child admission to the number of children. And so we have $4 for each child, and we let that have the variable y. We do know that the total that was collected is 1,590. So by getting, I would recommend going to the information you knew the total number admitted, and you knew the total amount collected to be able to set up your two variable equations. They're written a lot nicer than with my finger. So we have our two equations. We're going to go through the process again. I'm going to go to the easier equation that does not have any coefficients, and I'm going to put it into a slope-intercept form so that I can go ahead and graph it. Again, I tried to color code it. It looks like my red one needs to be just a little thicker so that you're not seeing the green through it, possibly. Move it just a pitch there. There you go. So this is my graphed equation, or my graphed line of the first equation. The other equation I left stay green. Here is the graphed line of that. If I look at these, I could identify them because of their y-intercept, their b. So 321. And did I have those reversed? I have those reversed in my color coding. I apologize for that. 321 is going to be this line, and my y-intercept of 397 is my red line. When the lines are graphed, then you can see the intersecting point is going to be at 150, approximately, we're going to predict it, 153. And for the x, this is our x, and our y is going to be 168. So if we go back to our original problem, x was giving me the answer of how many adults there were, and y was giving me the number of how many children there were. So we can see 153 adults and 168 children. When we add those together, we get the 321 people that came to the museum that day.